Hello. It's a Wandering Joe.
Yeah. All the way out here.
How's it going?
Good. Good. I don't know if CC's going to make it, but we were changing how we handled some of our meetings, so we would figure we would attend this one to cover some of the gatekeeper related stuff.
Yeah, that'd be awesome. Well, it is awesome because you're here.
Mm-hmm. We just show up. You don't have to do anything.
What's that?
We just show up. You don't even have to do anything.
They say 90% of showbiz is showing up. Not sure what to do with that in a programming context, but
I mean, I'm pretty sure I've seen a couple people that think their job is just to show up to meetings. I'm not sure I agree with them.
I mean, are they not presents?
Hello.
Not at this meeting.
Yeah, I appreciate that. Hey Rita, how's it going?
Hey, welcome, Joe.
Good morning. How you doing?
Could be better.
What's
Hanging
wrong?
in there.
I don't know. I'm under the weather. I think I have something for what it is.
This is your last meeting of the day then, yeah?
I wish.
I mean, clearly it's got to be the most important meeting.
Is we waiting on people?
I was about to ask.
I think we could probably start. Right. Sertaj, are you saying something?
I was on hard mute. Do we know if Davis or Alex is joining? If not, we can start.
I do not know. Let me see. Yeah, I haven't seen any messages from them. They can, we could just fill them in if they come in a little later.
Looks like we have Joe on the agenda with the cell mutation kit.
Yeah. Yeah, I don't know how much detail everybody wants on this, but I know with OPA Gatekeeper looking at using some of the upstream workaround cell for certain things, it might be interesting to talk about mutation now that validation is in alpha and we kind of know what the shape of that is. So I have a cap. Should I share it? Would that be useful?
Yeah.
the screen real quick, just so we can talk about it. So I won't be able to cover everything that's in here, and anybody wants to read all the details, there's a link in the notes, but hopefully everybody can see this. So the basic idea is that, kind of like validating the admission policies, we're going to have a new Kubernetes resource. It's just we put mutating in the name. And a lot of the stuff stays the same. So the way that you pick which resources you're going to validate or mutate doesn't change from the way that we pick things that you would validate. The only thing that's really different is that we need to have some way of expressing a mutation in cell. And it turns out there's a lot of different ways that you could do this. And so there's a bunch of alternatives. I think I listed some of them down at the bottom. But the way that we're going to do this KEP proposes it is that we're going to take advantages of some existing Kubernetes concepts and try and compose them together in a way that is not super surprising to people that know those concepts. So Kubernetes has this idea of server-side apply and apply. And this shows up a lot. So if you're working with Kubernetes and you've got a bunch of YAML files and you do kubectl apply, you don't have to provide every single field in a pod. You just provide the ones that you care about. And then when you apply that to the server, it creates an object with the information you had, and then controllers will hop in and add other fields to other parts of the object. And eventually you'll end up with this much larger object. And so it's actually a pretty natural mechanism to express mutation because the server-side apply allows you to send a part of an object that you care about and just change that. And that's kind of what we want for mutations. I just care about a part of the object, so I'll just send you that part and you just change that part. And there's a bunch of detailed rules about that, but that's the basic idea. And that's usually all you have to really care about. It's like, here's the part of an object I care about. So you're not writing a patch where you say, change a field from X to Y. You're just saying, here is a subset of an object, and it includes that leaf value for that particular field. So that's the idea. And you can express that in Cell because Cell allows you to construct objects, and it looks kind of like Go. So if you're familiar with Go, you kind of say like, here's some object, and then here's the fields of that object. And so you can do this in Cell. Now we have to pick what we call our object types. And the way I've in this example, I've shown it, and we might work out some details, but the way I've shown it in this example is that the type of the root object that you're mutating is just called object. And the type of the spec field is called object.spec. So this is actually a type, and this kind of goes on. This hopefully is not super surprising because it matches kind of like what you would know intuitively about the schema from the perspective of somebody that would be writing this file. You could choose to do it differently. Like if you go look at our Go structs, if this is a pod, this would probably be like v1 pod dot, v1 pod or v1 pod spec, and there would be no like dot notation for these subfields. And you would just have to know that this is like core v1 init containers. So this is a different scheme for naming types than we use in Go, but that's what I was proposing here. Now, within that object construction, you can still use Cell expressions to do things, right? So here, starting with this square brace to the end of this square brace, I'm actually constructing a new list, and then I'm appending pre-existing objects from the old value before this mutation took place onto it. So this is actually a prepend. What I'm saying is I'm going to prepend one more init container onto the list of containers. And so I'm just kind of like, this is actually fairly close to how you would do it in Go. And in many other languages, like I'm taking a list, I'm adding something to the beginning of that list, and now I have a larger list, and I'm saying that I want the value of that object or the value of the init containers to be that now. So that's the general idea. There are corner cases in this because you have to have some way to express like the removal or unsetting of particular fields. I won't get into all that, but there are some details on how we can think about that and handle that based on me talking to the Cell authors and some other people. There is also, and I know Max, this is a topic that you've thought a lot about. There is the question of of how do we make these mutations as safe as possible. So I've tried to address that as best I can. There are certainly rough edges on that proposal, but one of the main thoughts I had was that whenever you do a mutation, you might also want to validate that your mutation occurred. This is really common in Kubernetes. So if you look at any of the built-in mutators, like I think always pull containers or whatever it is, there are basically any of the mutating admission controllers that are built into Kubernetes. They mutate something, and then later, after all the mutations have happened, they have a separate validator that makes sure their mutation still is in place and that it hasn't been undone by some other mutator that happened to get run after theirs. So that's like one of the big safety nets that we've traditionally used in Kubernetes to make mutations safe. And so I was thinking, in this KEP, I have a rough proposal where like you can, one of a couple different ways, you can express the validations you want to have happen that ensure that your mutation did what it was supposed to do. Now, there are some cases where you don't really expect your mutation to exactly have happened. So a classic example is if you're adding a sidecar into a pod, you want to hydrate the sidecar, but you also might want to allow a subsequent mutator to add more fields to it or change it slightly in some way based on some subsequent policy. And so those are a little trickier. And I've tried to address those with some ideas, which I've stolen from Max. One is that we try and apply mutators closer to the root of an object first, so that like in the typical flow, what would happen is if you add a container, that's closer to the root of the object than the contents of the container. So then anything that modifies the contents of containers is run later. It modifies the container further. And then when you validate, you only validate the stuff that you really, really don't want to be changed. Like if I want to make sure the sidecar is still there, I just make sure it's there. And I only check the fields that I actually care about. So in this example, I'm only checking that the name stays the same. And I'm explicitly saying like, you can literally change anything else you want about the sidecar except for the name, which is probably a little too loose. Like you probably might want to check a couple other things. But as an example, you get a sense of like the selection you get to make here. You get to pick what you care about when you validate your mutation. And there's still some rough edges. Like I'm pretty sure that if you really, really wanted to, you could probably come up with a way to make like a cycle where two mutators fight with each other, and there is no like good outcome to that. And the system is probably going to allow both of those mutators in and just run them each a fixed number of times, and then you're going to get some weird output. So there are some imperfections to it, but those are, I think they're becoming increasingly rare and increasingly pathological the more we refine this. So I could use some eyes on that kind of stuff. But this is what I've been able to put together. Kind of the heart and soul of it again is just using Cell to construct a mutation request and then having the flexibility of the whole language to do whatever you want to do. I'll stop there and leave for questions.
Yeah, I have one that just about the how to express a thing, but the other thing, I think it's important to suss out the like players for safety and the goals as well. So tell me if you're I'm wrong about this, but I do think that the idea of a malicious or untrusted author of mutators is probably a valid case here, because we have people running like hosted Kubernetes deployments, right, where the author of mutators and the the cluster controller are in different companies. So that would imply that edge cases, as far as safety are concerned, are it's not, they wouldn't be rare because they would be exploitable safety holes, right? Like the malicious user would seek them out, which may or may not be fine, because like if there's a mitigation, right? Like, hey, if mutations don't converge after so many iterations, like lock down the cluster or something like that, which like de-risks from the cluster operator's point of view. Like you can't consume resources. And then the other side of it is a usability issue, right? Where particularly if we have something that's more portable and shareable, I imagine people are going to be mixing and matching mutators from various sources. And so there, I think something like this does make more sense, right? Where you're more concerned with edge cases such that mutators can that are written in good faith can self-detect when something weird is happening. And then it's about minimizing the chances that something bad happens. Yeah, I mean, ideally the chances would be 0, but there are usability trade-offs here. And the last bit I think is just having CNCF or Kubernetes get some sort of principled stance around this that has general buy-in, particularly from cluster providers, would be helpful, because the biggest risk I could see feature-wise is basically it being the security departments at various companies saying, no, this needs to be off, right?
Yeah, let's start at the beginning. So from the security perspective, I think we're in an interesting position where Kubernetes today has admission webhooks. If you gave somebody unfettered access to writing admission webhooks, they could own your cluster almost instantly. So that's kind of where we're at in terms of a really malicious actor. Now, there's the second class, which is it might not be the cluster administrator on a managed Kubernetes cloud might be trying to mess with the cloud or trying to break the cloud. That case, right now, webhooks, they're actually pretty successful, and they're doing it a lot more by accident than they're doing it on purpose. So a lot of people are breaking managed clouds on accident with webhooks. And a lot of that has to do with the fact that, the webhook is a remote call, and if the remote call times out, then they lose connectivity to their control plane. So some of that is pre-existing and gets slightly better with Cell. I'm actually a little less concerned with this than some of the other cases, because we're already making it better than it was with webhooks. And I actually wouldn't be super surprised if some cluster, if some cloud providers started to discourage or ban webhooks in favor of these mechanisms over time. They wouldn't be conformant, and that's its own bag of worms, which is if you're not conformant, you don't get to use the word Kubernetes in your platform anymore, and there's that. But there are some things going on there. I do think it's generally safer than webhooks, and I think it's safer on a couple dimensions. It's safer for cluster administrators because, unlike a webhook, which is just a pretty opaque binary, you can literally see the mutations that are going into your cluster. So, as an administrator, you should probably be very careful about who has permissions to write any type of admission control into a cluster, especially mutation. And the fact that you can now look at the mutation and see what it does in a uniform way is a pretty big improvement. Will these things converge or will they break by running repeatedly? Our existing stance with webhooks is that we do 2 reinvocations. We also have a problem, which is we have to put these mutations in an admission chain that already includes webhooks. And I can't undo that. So it might be that the other mutator that this is playing with is a webhook. And that's completely opaque. I have no idea what it's going to do ahead of time. So we will still have a limit on how many reinvocations are executed, and that will be one of our main safeties. And so it will be pretty critical that we try and order things in a reasonable way, because if something messes with your mutation, you might have one chance to fix it, and that's pretty much it. You can't like have two mutators go back and forth n times to converge to something. That's pretty much already not possible because we have webhooks in the mix.
Yeah,
It does mean, however, that we can limit the number of reinvocations we have. We just want to try and order things smartly.
I am a bit skeptical about the reinvocation thing. Like, I get it on a per request, right, that you can limit the reinvocation, but because you have controllers that like refeed an object into the API server, and the API server has little to no control over what those are doing. From a single request perspective, yes, but from like the overall object lifecycle perspective, it seems like the recursion is infinite to me.
Yeah, but it already was with once we put controllers in the mix. So we're not actually making that objectively worse. We might make it a little harder to reason about, because you might be able to just look at the controllers and prove that they're okay, and then you throw a mutator in the mix and it's not. But that's also true if you throw a third controller into the mix.
Yeah, I agree that it's not a regression in terms of security. Where I do see heightened risk for embedded is the decreased latency and ease of implementation. Like, if you had 10 webhooks, your mutation webhooks, you're probably going to time out. And so you get an effective rejection. And also mutation webhooks are difficult to implement, right? So in practice, you don't see many of them in the wilds. This does have the ability to change that.
Yes. Yeah, I wouldn't be surprised if you see more of this type of mutation in the wild than you do of webhooks for that specific reason. In fact, I think, but I'm also still convinced that a lot of people that want a significant amount of mutation or validation are probably going to still want a higher level abstraction. So they're probably going to come in through Gatekeeper or something. And hopefully those systems can help provide additional management, because at this level, we get a less holistic look at things as you do if you're like operating at a meta level.
Yeah, I feel like there's the like the what and then the value conversation here, right? Like what and the what is kind of like, what are the dynamics of like what people actually care about for mutation, right? Like it is my acid test of, you know, not turning the K8s binary into like a Bitcoin miner. You know, is that actually a concern in terms of and, you know, the ability of like cloud providers, honestly, to adopt it, right?
Now, one thing that we have in Cell that I don't talk a lot about, but we do have runtime constraints that are pretty stiff. So one of them is the cell interpreter is actually counting logical instructions, and we do put a really hard limit on it, and it comes in pretty quick. So anybody that starts nesting loops is very likely to hit it once their complexity gets a little too high. Now, if you're doing stuff that we consider well-behaved, you almost don't need to know it's there, because so many things are I mean, this is just so cheap. But once you start trying to like get into that range, you're going to hit it pretty fast. Now there has been a request to add hash functions, which I always worry a little bit about. Probably not useful hash functions for the purpose of mining, but still, right? Like once we introduce anything that is a little more computationally expensive, I get kind of worried. If we do add those, we're going to put a high synthetic cost on them, so you can do very, very few of them.
Yeah, and Rita is asking about how the cap changes our stance on what we allow for mutation in Gatekeeper. Like honestly, my first thought there is more along the lines of, once something like this cap exists, we have to face the question of why would you use Gatekeeper for mutation when you could use the embedded thing and not incur the network latency, particularly in mutations where things are more latency sensitive. So for me, my concern would be, one, is there anything that Gatekeeper can offer that is of value on top of mutation? And that's either like what we could do with the validating admission policy cap, where we're able to build on top of the mutation primitives, or because functionally there's mutators or stuff we could do with mutation that is just never going to be considered by entry mutation, right? External data is the example I always come up with. Or a third option here could be just syntactic difference, right? And what I mean by that is it's very possible that the syntax that internal K8s chooses can cover use cases that our current set of mutators would never cover. But on the other hand, our current set of mutators can do things like mutate everything with like a placeholder for external data, right? And so then you could parallelize out those requests. Like it's hard to know where the pockets of value are or what the story would be without a final design. And it's probably worth, I think, participating in the initial design, both for clarity on this question, because like the reason I harp on the convergence question is because it's like so deeply embedded in the syntax, right? And also just having a principled stance that I see everyone buy into also offers like a lot of clarity in terms of, how much of a big deal is this actually, and how are people looking at mitigating the risks?
I mean, I think you guys are thinking about good stuff. So one of the things that I'm not super clear on with this syntax is it seems to work pretty good as like, this is kind of the obvious cell way to do express mutation. But what I'm less clear on is this a good target for systems that already have a way of doing mutation and might want to generate this type of object under the hood as a way of implementing that. Now, maybe the answer is they just don't generate. They always are a webhook. But another option might be like, can I take a higher level representation of a mutation that, because the ecosystem might go and explore a lot of different ways to do mutations. And at some level in Kubernetes, what we want to do is we want to be opinionated enough that our API makes sense, but we don't really want to halt the ecosystem from exploring different ways of doing things. So at some level, what we're hoping to do is say, well, since this allows you to construct pretty much any applied configuration you want, and we already know that applied configurations allow you to modify an object in any way you want. In theory, at least for a single object, you should pretty much have unfettered control of how you want that object to look.
And that dovetails with Rita's question of, are all Gatekeeper mutators covered by this cap, which I think is interesting, but Surtesh also has a hand.
I was going to ask about things like a sign image, for example. So Joe, we added a new mutator that can mutate image tags, digest, registries, and whatnot. but we can only do it for everything, like basically for every container we mutate, or if we know the name of it.
Yeah.
The things that we usually, the requests that we get from the users are, hey, I would like to do this with a value test, or like if a parameter exists, something like that.
Yeah. So Cell does have a lot of operations that would allow you to do things like that. So one of them is, you could chain this even more. Here's an example of going through all of the containers. Map is just basically a for all operator here. For every single container, I am going to set the image pull policy to be always. I could even filter this, so I'm only looking at containers where I check individually various fields, and only the ones that have those fields in a particular setting, I do this. So you can be very fine-grained in like what you want your change to be, because you have a programming language that allows you to construct that change.
Can you reference things like metadata?
Yes. Yeah.
Okay.
So you could do like old object.metadata.label. If the label has some particular value that matches the name of this container, only then change the container. You could get pretty specific, as long as the inputs, as long as the object coming in and any other request information is enough for you to make your decision on how to frame the object, you should probably be able to figure it out.
And I guess coming back to Rita's question, does this change our stance? Because if we can do this with Cell, should we be able to do this with Gatekeeper?
I mean, if you can do it with Cell, why would you do it with like Gatekeeper style mutations, right? Like I would prefer not to have a webhook as a user for latency reasons, operational reasons.
We still want to keep like things like the external data use case.
For sure, but at that point, the question then becomes like, do you need external data, right? And then the syntax should, if external data is the only use case, and I'm not saying it is, but that's the only one I'm aware of right now, then the syntax that Gatekeeper has should really focus on optimizing for the external data use case while allowing everything else to be offloaded to core K8s, right? Just because that's the best fit for the users, right? Performance-wise, capability-wise, and also like honestly simplifies our job a little bit, right? Like if mutation needs to cover all possible use cases, that is a much heavier lift. Yeah, the allowing of arbitrary cell expressions is also interesting here. Just it still gets into Turing machine territory for me. Like I think definitely being careful about what kind of functions wind up being supported by Cell would be important there, because you could take an individual field, right, and turn that into your tape and use that to feeds recursively into a function.
Yeah, right now our function set is very limited, and so Cell is still non-Turing complete, and we can actually run things like what is the worst case cost of random expression.
Right, not Turing complete in the individual execution, and the issue with mutation is that implicit, like it's not the execution environment that provides the infinite loop in this case.
Yeah, no, once you get controllers in the loop, you're still back to that same case that we had before, which is like they're Turing complete and they can use the data in any way they want to achieve that.
Yeah. Let's see. I'm looking at the chat here. All gatekeeper mutators covered by this cap. I may need to poke around cell expression. See how we can cover the assigned image case. This is why I really like mutation validation. Assuming it could be used to check only this field was changed this way to ensure nothing else was modified. Yes, except that that assumes that the author of the validation, which is, again, the same as the author of the mutator, is trusted, right? In both senses of the word, right? That they wrote a good validation and that they intend to write a good validation. And yeah, it's,
I mean, it's in some way the incentives are aligned. So if you take a good actor, then they write the validation to make sure that their mutation happened.
right.
If you then put another bad actor in the system, they can't undermine that validation because
Right.
all validation happens after mutation. So they can't undermine any pre-existing mutations. They can certainly write a bad mutator, but the cat's kind of out of the bag on that, right? Like they could have done that with the webhook today. They can pretty much do it with controllers. It's up to cluster administrators to be judicious on like what level of access you want to provide with things and how you want to vet that stuff. And I think it's still quite a bit better than webhooks because at least in, well, it's better than random webhooks in that like you at least get really good visibility into what the mutator's doing. So if you choose to audit them, you have a good opportunity to do that. And you're not at risk of supply chain attacks, right? There's no external dependencies here. Now, it's probably not like, I don't think Gatekeeper, even though it has a webhook, falls in that category because it's not like a random webhook. It's a well-established thing. You know how it works. You can build trust with that. But at least compared to like just some binary that somebody's put in, I think it's a little better.
Right. Yeah. In the malicious stuff, that is more of a cloud provider concern. Like cluster operators, they can sort of choose who's allowed to do. They have a lot more power to choose who's allowed to do what.
Yeah.
Assuming that the cloud provider has delegated the ability to create these things. That is.
Yeah. We got another question. It would be cool to reference a validation policy. Yeah, whether or not we end up with the validations actually being in line here or not is a really good question. I proposed it here as kind of a way to force you to think about writing a validation, but I'm not sure if like mechanically, if that's actually the best choice, if people should just write their own validator separately or not. There is if you want to read through some of the details, I listed a couple different ways that you can think about validations. I don't know if I can find it right now. One was that writing an expression. One was basically just requiring that if you were to rerun the mutation, that it would cause no change, right? Like that's a way to validate a mutation is just take the object after all the mutations have been run, try and run your mutation again, and as long as it's adipident, then like you're good. Your mutation must have been applied. So there's a couple different strategies to this, and by pairing it with the mutating admission policy, you have the information to run some more of the strategies. The expression one you could just write separately. I hope.
I mean, I like this because it kind of makes people think that, hey, I should write validations for the mutations, because for the gatekeeper mutations, we always advise that in addition to writing the mutations, you should also pair it with a validation policy. So I kind of like that this is both integrated, so folks will think about it and not just like, hey, I'm mutating this anyway. Why do I need to validate it?
Mm-hmm.
On that end, though, the one thing about validation that I'm not sure how to overcome is the dueling mutators model, right? Like if you validate basically everything the mutator applies, and then you have a second mutator that say sets image pull policy to false, right? Just to say nothing of like verifying the length of the container list or something like that.
Yeah.
you can wind up in a situation where applying a new mutator renders an old mutator unhappy for whatever that means when validation is violated. And that could either be a good thing, right? Because these validators are here for a reason. Or it could be like a user pain point because, you know, all I wanted to do was override this one thing that this other thing was doing by default. And now I need to edit code in both, right?
Yeah, and that could get into the realm of like how do we configure the failure modes, right? Like right now we do have some very coarse-grained failure policy settings, but that may not cover. It's pretty much just ignore or fail. It may not cover some of the nuance you just mentioned, right? It might be that somebody's like, well, I don't know. Maybe I want to just warn if the validation fails or audit if the validation fails or something. Right now, there's no way for us to express that. So that would be a good area to jump in on the CUP with the concerns, and we can see if we can refine that. This is also something we would have a chance to do in beta too, is try and figure out where those pain points are, what the different failure modes are, and how we can cope with those. Webhooks had, I think there are fewer webhooks installed, but the main place where people actually saw mutating webhooks fight was literally the sidecar containers case, because it would interact with the image pull policy, which I showed an example down here. There is a built-in controller that can do this. A lot of people like to have it on. And so it's very likely that if you have sidecars and this, that you're already in kind of like one of those modes where the mutators start to fight with each other. And if those get ordered wrong, like this one is run before the sidecars, then you end up with sidecars without the pull policy, but the pull policy is also paired with the validator. So now it's going to fail because a sidecar was created after it did the mutation, and that doesn't have the pull policy, and now you fail validation. So that was actually one of the main cases that causes to introduce reinvocation. So will we end up with like larger, messier, complicated chains of mutations? Maybe. I feel like up till now, the trend has been some mutating admission and a lot of controllers. And I'm wondering if that ratio is going to change and you're going to see more mutating admission relative to the number of controllers. And if so, what does that mean?
Sorry, I think 100% you'll see more. And not just because it's like now relatively easy for people to write mutators. I think there are cases where people have written a controller now, right? Like third-party projects where they will instead write mutators because they no longer need to.
Yeah, we've seen people write validation in controllers because they didn't want to write a webhook.
Yeah. Well, and there's also kind of the technically it's abuse of validation controllers, I guess, where people use a validating webhook with a side effect in order to achieve a controller-like behavior without the need for having that controller loop. Cell is probably the validating admission policy stuff probably won't be vulnerable to that kind of usage because it's fairly not featured for that kind of approach. Mutation I could see though, because it is like in-band, it does allow you to modify the object. If people are willing to risk drift by not having a watch, which is actually much less of a risk now because it's in the API server. I think it replaces a lot of controllers.
Yeah, okay, I just got a reminder that we have 15 minutes left and there is another item, not cell, that's on the list. So I do want to yield some time to that. Yeah, Rita, your question about ordering. Yeah, we're thinking about ordering stuff based on like how deep it is in the tree so that you get shallower stuff first. But I'm very interested in feedback on that. should we switch over to the other topic? We can always talk more about cell in the future.
Yeah, the friction stuff, there's controller runtime anyway, before we can really push forward on that, which they're cutting release.
All right. Well, thanks for your time, everyone.
Thank you, Joe.
Yeah, thank you.
Thank you.
The next item I put on the agenda was the V3 change in the Go mod. I think this is the Gator change we were discussing. Let me find that. Putting it on the agenda. 1 second. This one, yeah. So I think to be able to properly handle this, trying to make it like, we will have to publish Gatekeeper as V3.
Publish it in what sense?
So changing the Go mod
Okay, gotcha.
thing is V3 / whatever version. Because I think if we publish it with 0.3 and V3, I don't think that's going to work, because then it's just going to be more confusing. And then I don't think the Go system will pick it up, because I think I put a link on the issue. Like, for example, for Kubernetes libraries, they publish with a version and something like Kubernetes -1.21 or whatever. So we would have to publish with a V0.3 and Gatekeeper V3.
So it's really the like prefix that prevents GoMod from being confused.
Yeah,
is what you're saying for Kubernetes.
So, and then that ship has sailed for us, obviously, because we already published extensively. And then I think the only way to properly fix this is basically changing our thing to V3, and then that's going to break. If any repos have like dependencies over Gatekeeper, that will break all of them.
Yeah, I mean, not too terribly. Like, they'd need to rewrite their imports. Joe,
it's not that bad. It's just like one thing they have.
You look like you're having thoughts on this. Does this ring familiar to you?
I'm sorry, I was multitasking. What was the topic?
No worries, no worries. Yeah, this is just we called ourselves V3 for our semver, which has implications for GoMod, and so now we're trying to make our package more importable, basically. Yeah. So, no need to weigh in if you didn't. I just saw your mouth moving as like, okay.
Yeah, these are always fun ones. Let me read up and see exactly what you did. You've got 0.3. So you've just been bumping a minor version on a 0.
Oh no,
V3.
Yeah, we are already V3, so we've been bumping the minor versions on V3, but then the Go mod is still on like V1 technically.
Oh.
So that gets like the plus incompatible thing in the Go mod stuff. And I think a few users wanted to get Gator, which is our like CLI through GoGet, and that obviously does not work if Go doesn't think that's valid.
Yeah.
Oh, I didn't realize this was for Gator. I thought this was people were trying to import.
Oh no, this is for Gator. So I think one person wanted to do go install whatever. And then this another person wanted to utilize some packages in PKG Gator and for static analysis. I don't know what that meant.
Oh, they want to basically like analyze constraints and templates probably at rest. Interesting. Well, I think this seems like a reasonable approach. Was there any? Were you just like looking as like a heads up / space for objections, or did you have?
Yeah, basically, yeah. I opened a draft PR. I didn't know if people would object, like, hey, we can't do this because it's going to break this random thing, because we'll have to like change everything also for our ecosystem.
Right.
So if we are like taking a dependency on Gatekeeper or any projects, I know we do for the external data provider maybe. So some of them will need to be changed.
Yeah, I mean, is there anything other than just rewriting the import path that people need to change, or is it?
No, that's about it. I mean, I just did a big find and replace, and that was about it.
Yeah, like it's annoying, but
Yeah.
there will probably be worse breakages because Gatekeeper. I haven't. Has anyone else been thinking about it as a Golang library versus application.
So I was going to say, Max, I've run into this as well because I do use it in some of mine internal CI tests and for pulling in Gator Go mod. And yeah, I have to use pseudo versions right now because of this, which doesn't bother me. But yeah, I definitely noticed, yeah, you can't pull it in with v3 because since the URL doesn't end in v3, it'll reject it.
It's cool that you could just like rewrite the Go mod though, rather than move all the files.
Yeah, it was pretty painless. I mean, unit test is flaky, but that's about it. But it was a big find and replace.
I have found that some of the Go mod versioning is not super intuitive to users. So it might be that you just write a short document somewhere explaining like the common use cases and then just link out to the official Go docs for further details. Like you don't want to rewrite all that. But I have found that sometimes can be enough, is just like show people a couple of the core examples and how to do it right with your project, and then just reference that to people and let them get used to it. I can also look over the way you've done it, see if there's any ideas I have.
Yeah, like just saying, just like go get open policy agent / gatekeeper at whatever.
Yeah.
And, yeah.
Like how to install Gator and that sort of stuff. Yeah.
Yeah.
And they should definitely be called out in the release notes in the next version as like a breaking change sort of thing.
Cool. So I personally, it doesn't sound to me like anyone has objections to doing this.
Yeah, I'll go ahead with my PR then. Thank you.
Yeah, thank you.
Might be good to just do a quick like GitHub search to see how many projects may be using Gatekeeper. Like,
As a library, yeah.
yeah, just as a sanity check, I guess.
Yeah,
No.
I mean, they will have to move. I mean, we can see who's using it, but they will definitely have to move.
I definitely like to know those numbers just generally. I'm curious.
Oh, I mean, it's all visible in the, if you click on use by, let me see.
Oh.
I'll put it in the chat. I think everybody should be able to see this information.
Network dependence. Lots of Caverno.
Yeah,
Interesting.
funny.
Oh, wow. It rolls into the next page. I wonder how many of these are forks.
Yeah, GitHub doesn't really distinguish between forks so much. Yeah.
Yeah, I gotta filter that somehow.
It mostly seems like a few of the same flavors of projects, right? Like I'm seeing a lot of Terraform validator, some Caverno, config validator, integrity shield.
Yeah, on GCP side, there is the Cloud Foundation toolkit, Terraform validator, KPT functions SDK, and config validator. Those are at the last page.
Gotcha.
And
Yeah,
I actually
okay.
maintain the Cloud Foundation toolkit usage of that, so don't worry about it.
Sort by start. No, I'm just kidding. Yeah. Cool. It's not like an endless scroll. It's like 3 pages though. So
And sometimes it's a good sanity check. What you can do is find like one of your biggest downstream things and go in and see if you can figure out how to update them to your change. If it's trivial, I sometimes just delete my PR, like delete my branch. But if it's hard to do, sometimes I might even open it against the downstream thing just to kind of be like, here's how you would do it. You don't have to take my PR, but I just wanted to show you how the change looks, and you can accept it if you want.
gotcha.
I wouldn't do it for all of them. That's way too much work. But sometimes you have something big downstream, and it's, if you can do the hardest one, then you can show the later ones. Oh, here's how I did it for this project. Just follow this model.
Cool. All right. Any other? We have like 3 minutes if we wanted to do the milestone check-in, or if there's anything more we wanted to do here.
Yeah, we certainly don't need to do anything specific for it. Just wanted to add the time at each meeting to do a quick couple-minute check-in. Let me just real quick make sure that this public-facing roadmap, which I need to change the privacy settings on it. This is still looking right to folks, and we're still on track for things.
Yeah.
Cool.
I can only tell you, I know we're actively doing work on the validating emission policy. I saw review feedback for pub sub interface from Surtesh and requires sync data as active effort. I don't know about cache response for external data. I know we're interested in it. I don't know if there's any active development work right now on that.
Which one? The cache response from external data?
Yeah, number 1.
Oh, okay, yeah, I think Nilek was going to look at that one. I think he assigned to him.
Gotcha.
Cool. That's all I had. Just a quick check-in.
Cool. Thank you. What? My cat is unhappy. Doesn't like a roadmap.
Well, looks like we're on time now. Nice seeing everybody, and thanks for the presentation, Jeff.
Yeah. Thank you very much for stopping by.
Yeah, thanks everyone. I'll see you next time.
Bye.